I am blue.
All right, guys. I am very ready for this weekend. I don't know if you guys feel the same way, although it's going to be full of catching up with grading, but that's okay. Anybody have questions from homework stuff? Anybody realize what is currently scheduled to happen next week? Nobody wants to say anything.
It's another quiz.
Yeah. And it's so I'm let me think. I was going to offer, so I'll tell you this. If I keep it on Monday, I'll do 5-3, 5-4, 5-5. If somebody wants to push it back to Tuesday, then it's going to cover 5-3, 5-4, 5-5, 5-6. It might be unfair of me to put that up for vote. That's kind of a rough one. I'll tell you this. I'll try out. I'm trying out something new this semester. Like it's called Being Nice. I don't like it. I've done it a few times. It doesn't feel right. But I can push it back to Tuesday and have it just cover 5-3 through 5-5. Is anyone opposed to that? If you are down, speak up so everybody else can find you and convince you otherwise. No. Go ahead, Brian. Everybody concur? You guys concur? You're not opposed. Okay. So what I've done is on, oh shit, what I just did was close everything. Why not, Jeff? Shit. All right, I gotta reset things. So what I've done is on Canvas, okay, you only live once, sure. On Canvas, if you go there now, you go to modules, in the Unit 5 module is basically what was once part of my practice test. Let me show you this. So if you go to Unit 5, right, which of course is right after Unit 3, because I can't count, because Unit 4 didn't really, it was nothing in there. This is new, section 5.3 through 5.6 practice. It's just to give you an idea of the way I like to ask questions. So for the test, for the quiz on Tuesday, it'll cover 5.3 through 5.5. So these two won't be on it, okay? But yeah, I'll keep those up there. So if I remember, maybe somebody can shoot me an email, remind me. I can make a little video going over these four. Or let me think. Or I can do them in class on Monday. I'll figure out which one I want to do. All right, so you got that up there for extra practice, and at some point, the solutions will be covered, right? As you glance at this, does this sound familiar? Does this sound like something you could like sink your teeth into? Right, end behavior, intercepts, behavior at the zeros. What the hell does that mean? Behavior at the zeros.
Like if it crosses or touches the x-axis.
That's right. That's right. And then graph. This one I want to talk to you about because I can't remember. I might have done this and I did it quickly. Have I shown you how to find zeros with the graphing calculator?
I believe not.
I think you did. I feel like you did.
Yeah, I feel like I did something similar.
Because it's just second calc zeros, right?
Yeah, but then it asks you 3 questions, right? It
doesn't just ask for left bound and right bound.
Left bound, right bound, guess. Yeah. So let me show you real quick, just to make sure everybody's got the same recollection. Where are you? There you are. Okay. Click on that and wait several seconds for it to open. Oh, yeah. So I think from now on, the quizzes will work basically the way the last one did. Let me see. Moved you guys over there. Oh, shit. I moved the wrong thing over here. Hold on, everybody. Get over there. All right, let me open this up. Okay, let's put in here. Let's just make up some really disgusting. Let's see, 1.78 x to the 5th minus, let's not make it too crazy, Jeff. 2.1 x to the 4th. Man, and what's really dangerous about this is as I make this thing up, it could end up having like only one. Well, we'll see what happens. I don't care. Whatever happens, happens. Let's do this squared, and let's do minus 2. So if you want to play along at home, you can put in that same stuff. So this is obviously nothing I want to do much with by hand. Synthetic division will work with decimals, but no thank you, right? So let me do, has everybody got that sucker? Somebody tell me right now, how many zeros must this have? How many total zeros must this have?
5.
5, yeah, right? Do you remember what that was called, what you just used?
It's just the highest degree, isn't it?
That's right, that's right. I like it. So that's the idea. I don't care if you remember the name, but it is the fundamental theorem of algebra. So it's like, you know, the bedrock. So the highest degree tells me how many zeros it must have. Some of those zeros could be repeated, right? In fact, well, anyway, some of those zeros could be repeated. Some of them could be complex, but there must be a total of 5. Where are you? Where's the camera? There's. So let me hit zoom 6 just to kind of start off and see what I've created. Yeah, I knew it. Well, let's see. Maybe it comes back down somewhere. What kind of end behavior should I have? I don't think it's going to come back down, is it? Because what kind of end behavior should I have? Let me go back to it. What kind of end behavior does this have?
It's cubish.
Cubish, right? The giraffe without a leg about to fall over. All right, so the graph kind of checks out. Let me see if I can do one little thing. Do you guys notice now? Now look, this is not a problem that we were given by the book. This is a problem I made. So guess what I could do? I could change the damn thing. How can I very quickly guarantee that I get 3 real roots?
Is it where the graph starts to decrease and then ascends up?
So what
infinity?
can I do to make those become roots? I have to take the graph and I have to
Shift it up to.
shift it up. Yeah, let's see. If I shift it up 2, that's going to be too much. Maybe not. Let's see. So let me go over here and make this. We might as well be really, really careful and make this minus 0.3. Let's see what that does. Yeah, dude. And I'm going to do one more thing. Is everybody with me so far? So that'll be our new function. That's the function we're working with just because. And the last thing I'll do is I'm going to use my favorite thing, and that's the CSI enhance, the zoom box. Enhance, 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 enhance. You watch too many shows. So up we go. So if I do zoom box, I can hit enter for one corner of the box, and then I open it up. I think I could just hold the button. Let's see. Yay, Jeff, look at you learn. Enter, and it zooms in. Look at that. That's so beautiful. That's going to be a lot easier to handle this business. So can somebody tell me right now how many complex zeros does this apparently have? Recall how many zeros it was supposed to have.
I was supposed to have 5.
Yep. So how many complex does this apparently have?
3.
2.
No.
Oh,
Two.
2, yeah, 2.
It has 3 real. I like it. So Bahazi, right? So it's got to have 2 complex. I'm pretty sure none of these are repeated because they do look pretty linear as they go through each of them, like it's a first degree thing happening there. I like it. So none of them have multiplicity to cover the missing stuff. Anyway, so how do I find, let's find, I don't know, doesn't matter. Let's find this first root dude over there. So trace is not good enough. And we're there. Okay. It's not good enough because y isn't exactly 0. So does anyone remember how I do this? I think somebody said this just a minute ago. I'd hit second. Trace. Crazily enough, we're going to do the one that says 0. And then it comes up with 3 questions. What is your name? What is your quest? No. Left bound, so you hit the left arrow a couple times. Go back. Right bound, you hit the right arrow a couple times. Guess. So then you go right on top of the answer. Bam. And now we got the exact 0. And then you just do the same thing for that one and that one. What's funny is we use TI calculators all the time. There's a Casio calculator that you just tell it to find the zeros and it finds all of them. You don't have to give it any bounds. You don't have to give it any shit. This one kind of sucks because you got to do all this for each one.
I have one of those Casio.
You have that?
Yeah.
And does it do what I say? Do you know how to do that?
Yeah. I don't remember. I don't have my calculator with me, but yeah, it does. It gives you the zeros. It gives you the exact zeros.
I think you got to do a lot less work than we do on the TI, but oh well.
But there's some stuff you can't do with the Casio that you can do with the TI. So it kind of sucks also.
All right. So it's a bit of a give and take. So let me do that one more time. Somebody's requesting me to do that one more time. Let's do it for another 0 here. Let's do this 0. So if I hit second trace to get to calc, choose 0. You can hit the number 2 also, it doesn't matter. Oh, I'm way over there again. So get your cursor right on top of the answer and then the left bound. You hit the left arrow a few times, enter. Get back to your answer, then right bound, hit the right arrow a few times, enter. So see how it opens up a little place to search? And then my guess, I go right on the answer, enter. Maybe that's what somebody forgot to do. They said they couldn't get y to be 0, but did that work better out there? Hello? Hello? Oh, good. All right. You don't want me to start singing. Good job. You got back to me. Is this a 0 you're looking for? All right. All right. So that's how you would do that. I like it. I like it. Somebody remember, I know I did this. How do you find this maximum right there? This local max? So I probably go back to second trace calc, and of course, you know, then it's really obvious. Maximum. And it's going to ask you 3 very familiar questions. Left bound, enter. Right bound, enter. Guess, enter. And then I get the maximum. Woohoo. Okay, enough. All right, I'm going to stop sharing now. Okay. Oh, let me spotlight myself. And let me figure out how to see everybody again. Or the few of you that actually have your videos on, thank you so much. You maintain my sanity and I appreciate it. You like my sanity patrons.
Can you
yes.
go 30 on 5.5? I've tried it like 20 times and none of the answers are working.
All right, let me see. Here we go. Open the book. 35.5?
Yes.
Okay. Let me share this bad boy. Over there. Share this. Bam. So the instructions on this one, use the rational zero theorem to find the real solutions to each equation. Okay, so yeah. So now this is where you want to list out all the possibilities, right? And you're looking at this one here, right?
Yeah, I listed them all out and I tried every single one, both positive and negative, and none of them are going into the equation.
Yeah, gummit. Did they
But
give us?
I did the
both?
calculator thing you were saying, and there are 3 zeros. But
Did you see what they were?
yeah, they're basically the same thing, but when I plug in the values, it's not working. It's like a negative 2/3, negative 1/3, and then the other value is not one of the three.
So let's do this.
Not a rational value.
Possible you can do it, Jeff. There you go, buddy. Possible rational zeros. What would that list look like? So I put the factors of 6. And I know you already did this, just making sure everybody else. And then on the bottom, go the factors of 3. I don't need that there, Jeff. So you got 1, 2, 3, 6, and then a bunch of fractions. 1/3, 2/3, 3/3 is 1 already there, and 6/3 is 2. It's already there. Yay! All right, plus or minus all that business. So let's just do one that you said works for sure. Right, so something like, what'd you say, 2/3?
Negative 1/3.
Negative 1/3, okay. So 3, negative 1, negative 11, negative 6. So let's see, this is looking, let's see what happens. Right, so bring the 3 down. Negative 1/3 times 3 is negative 1. Add, multiply. Oh, this is where things get gross, huh? So I get, yeah, 2/3. This is not going to look good. So negative 11 plus 2/3 is negative 10 1/3, which is whatever the hell it is. Negative 31/3. Yeah, that's not looking good, is it?
Oh, I think maybe it's a positive 1/3 because in the graph it's a negative and you flip
Oh,
it.
well, there you go. Yeah, maybe. Well, I don't know. Let's see. Would that make a difference, Steph? Yes, it would. So I'm not sure. So you're just having a specific problem with, I'm really curious, though, where this is going wrong for you. Let's see. So 1/3 times 3 is 1. These add to be 0 this time. 1/3 times 0 is 0. And then I get, and that's still not going to work. Negative 11.
That's what
So
I
let's
was
check
saying.
that. All right. Say again.
Yeah, that's what I was saying. It's like I don't understand because it doesn't work, but it says that it's a 0.
Well, let's find out. Let's make sure. In fact, the quickest way to figure it out is just to plug a 1/3 in and see what happens. But let's find out what's going on. So I'm going to put this sucker in the calculator, and then I'll share it with you. All right. That was quick. Let's see. Where do you guys go? There you are. All right. So that's the function, right? Double check me on that. Yep. Okay. So now if I graph this bad boy, resume 6. Yeah, and so, all right, so if I do find a 0, let's see. So this looks like it's negative 2/3 actually is what it looks like. Let's find out. do it, Jeff? Yeah, that looks negative 2/3. This is kind of nice. I'm okay with this. Because why wouldn't I be okay with this? So it's kind of showing you how you can kind of double check yourself with the calculator. So if I come back now, let me come back. And put this back over there and then share, oh shit, I don't want to do that. Share this guy, not you. Okay. So we were just trying negative 1/3, right? So let's try negative 2/3. Where'd it go? 3, -1, -11, -6. So I'm just going to do this a little quick because now I'm very curious. Now this looks more like it's going to make sense because now this is going to make another multiple of 3. So when you multiply, it becomes 2, and then you get 9, just like you should. Yeah, this looks like it's going to be fine. Negatives cancel, and then you get 6, so that works beautifully. Now, another reason why I'm perfectly cool with this, is that all right out there? Do you see what you might have done wrong? Did you?
But don't you plug in a positive 2/3 because you're supposed to plug in?
Okay, now watch. If my function was this, what are my zeros?
1 and -4.
Exactly. So if I see a 0 at -4, what does it relate to? This. So you're thinking about changing the sign in the wrong place. Now I understand what happened. So there was a 0 at -2/3 for the function we just looked at. There was a 0 at -2/3. So of course I'm going to put -2/3 in there because it would have come from x plus 2/3. That's the sign that I change. I don't change this sign.
Oh,
Are you?
okay. I don't know
Yeah,
why
yeah.
I thought you're supposed to.
No, it's okay. It's okay because there's sign changes and it's kind of weird why it happens one way or the other. And we don't normally take like a root that we know and put it in here. So we're sort of used to changing the sign, but the sign is already changed once it's actually a point on a plot, right? Okay. The other thing I want to point out is this isn't the point of this problem, but how would I write the factored form of this so far?
3x² minus 3x minus 9.
True, and what goes here?
Times x plus 2/3.
And what we normally do you guys see that? So you would never do this and then write, you would never do that, Jeff, and then write this. You wouldn't. So look what I can do though. Look what I can do. Can't I take a factor of 3 out of this and apply it in here? So this becomes 3x plus 2. And this becomes x² minus x minus 3. So there are a few people that did the homework that I am crossing through this because you wrote this and you wrote this together, and that doesn't make any sense. Do you guys see that? That's the one thing you got to be careful about when you're dividing by what would be a root for something like this. You can't just say that that's a piece of the answer because that comes from this. It comes from this by definition. It's always x minus the thing. The extra factor of 3 that kills my fraction comes from the other dude. Does that make sense at all? Especially for the people that, I don't know if you've looked at the homework I graded earlier. A few people were making that kind of mistake. Okay. That's not got anything to do with this problem because they didn't have to worry about writing the factored form, but just to make that point. All right, I like it. Anybody else questions? All right, I'm gonna stop sharing. Stop. Okay. Now I want to do something that I want to go back a step and really, really, really tease out the reason these rational functions look the way they do. And this is something that you're going to do in calculus if you are going to take calculus. Oh yeah, all right. All right, let me see. That's really bad. Sure. Shit. Oh, the room is tilted. Hold on. I have to get somebody out here. Is that like really push you back a little bit? There we go. Oh, cool. Okay. Give me a minute. All right. If I have a function like this, you make a table of values. This is kind of a neat idea. And I really want to make a point that, again, it will help out with calculus. It's in the book also. If I ask you, why is this question not specific enough? As x goes to 2, what does f of x do? That question is not specific enough. Why? So let's investigate that, right? So let's investigate that. Let's make a table of values. So here's what I really love when I teach calculus. I love, has anyone ever seen the movie The Blob, especially the 1980s version? Anybody? There's at the beginning, meteorite cracks open, homeless man comes over, not a bright bulb, actually touches the damn blob and it goes over his hand, blah, blah, like it's. So if there's something you don't know and you're like, I don't know what that is, don't you get really close but you don't get there, right? You don't put your hands on the damn thing. What is that? No, that's not something we normally do, right? Unless you're in a horror movie and you need it to move the movie along. So what I'm going to do is I'm going to put values in that I'm allowed to use, but they get really, really close to 2. So for example, what if I put 2.1, 2.01, 2.001? That is the technical look of what this means. But to be honest, that's the technical look of not what that means necessarily, but what this means. This is x goes to 2 from above. X goes to 2 from above, or let me say it a better way, from the right. From the right, right? So when I say above, I mean in terms of x's. So I've got this weird 2 that I'm not allowed to use. So I'm going to approach it from this direction and see what happens, right? What the hell is that? And then my buddy's over there, hey, Frank, come over here from your direction. Come over and get really close to this weird thing. Anyway, sorry. So help me out. What happens when I put 2.1? This is something we don't even need calculators for, believe it or not, you just don't. What do you get? 1 over, what's 2.1 minus 2?
0.1.
0.1. 1 divided by 110, 10. And then 2.01 minus 2 is 0.01. 1 divided by 100 is 100, right? So what's this going to be? It's going to be crazy.
1,000.
And of course, if I kept getting closer and closer, that's just going to keep getting bigger and bigger. So as x goes to 2 from above, f of x goes to infinity. Now you guys do this side. 1.9, 1.99, 1.999. And that should be really quick. There's just one thing to be careful about.
So it's 99. No, 9,000.
No, stop. You're overthinking it. So if I do this, what's 1.9 minus 2?
Oh,
They're going to be the same answers. They're just going to be negative.
Yes, there you go, because it's negative 0.1, right? 1.9 minus 2 is negative 0.1, so you get negative 10. This will be negative 100. This will be negative 1,000. And this, of course, is x going to 2 from the left. So when you see something like x approaches the little plus sign, what's happening out there? Mute everybody real quick. Okay. As x goes to a from the right, that's what that means. So you would use numbers larger than a and let them get close to a. And the negative would just be the opposite idea. So what is x? As x goes to 2 from below, from the left, what does f of x do? It goes to?
All right.
Negative infinity.
Well, negative.
Negative infinity, right? As x gets closer to 2 from below, from the left, the outputs get bigger and bigger, negative. So it's going to go to negative infinity. So that's why this looks like, where's the vertical asymptote again? We already know.
2.
2, yeah. That's why we're getting really close. Got a wall there. And we're like, that wall wasn't there yesterday, so we get walk really close to it. And when I'm coming from this side, from above, it's positive infinity. And from below, it's negative. And of course, I'm throwing in there one other thing we know. We know that the horizontal asymptote is y equals 0, right? Okay. So, let me let you get whatever else you need from there. And then let me throw one little wrinkle into this. All right. Could you tell me, without doing any real work, what would happen if the function was written in blue? I mean, if the function was 1 over x minus 2 squared. What would be the biggest visual change between this? You can do it. You can do it. You can totally do it. What's not going to happen here that happened there?
It won't go to negative.
Yeah, so it'll be up here. I like it. It'll also be steeper and all kind of shit, but the basic look of it will be, it'll look the same over here, but over here it's going to do this. And to me, that always looks like some infinite volcano, like there's, the lava's coming up, but it's never going to get to us because it's freaking infinite volcano. That is why you see this kind of thing happen sometimes, where they kind of mirror image each other. It's because there was an even multiplicity on that vertical asymptote location. So they mirror each other on both sides. All right. Any questions on all that stuff we just covered? So you will see these kind of things in there. You will see a couple problems that say make a table to attack something. Okay. I want to do another example of a full rational function and graphing it. We did one yesterday. All right, so I'm going to erase my aquamarine volcano. All right, so let's try a more interesting problem than what we did yesterday. What you got, Jeff? I don't know, man. Sure. you could do it. Totally do it. There you go, buddy. And then down here, let's just do this. No, let's do this. Yeah, sure, why not? Ha, sorry. It's gross, Jeff. Well, too bad. All right. So the very first thing, and what I normally do on a quiz or a test or whatever, what I normally do is I'll kind of do A, B, C, D of these things. So most of the time, the first question will be find the intercepts. So do that. Second question would be find, is that an F? What is it? Find the asymptotes, the vertical asymptotes. Find the horizontal asymptote. All right. So see if you can do all those things. This shouldn't be too hard, right? Let's see, 4/3. Where does this always come from? Where do I always get the vertical asymptotes from?
The 0 of the denominator.
Yeah, where the things that aren't allowed to be in the domain. I like it. So the one thing you got to be careful about, of course, is will there be any holes? And when is there a hole instead of an asymptote? Anybody?
If there's an asymptote, then y would continue to approach infinity, right? F of x would continue to approach infinity. But if it's a hole, you won't get an answer.
But what would happen in my function to make it a hole instead of an asymptote? That's the question. So if the bottom had a factor that was x plus 2, it would cancel with the one on top for every value except -2. So there would not be an asymptote there, but there would be a hole there. I like it. So my vertical asymptotes, of course, if you want to factor this bad boy, you get. So what are my vertical asymptotes?
3/2 and -3/2.
Kick ass. And what situation am I in for the ha?
Is it 1/4?
Yes, degrees are the same. So it's just the ratio of the coefficients of the highest degree terms. So I get y is 1/4. Like, all right, so now that I've taken up all my space, let me see, let me just give myself a little more space. All right. I can try to start plotting this out. So I can see that I need to get up to 6 over there. That should be decent. I'm going to figure out this scale in a little bit. What can I plot on here? What can I start to throw on this sucker?
Your x-intercepts.
Yeah, my x-intercepts. Those are always safe, right? So I call those my anchor points. So 6, 0, and -2, 0. What else can I put on there before I know this scale?
Y-intercept.
No, yeah, until I make this scale, I can't plot that, right? But there's one more x thing I can do.
Your vertical asymptotes.
Yes. So at negative, why is my scale so sucky? At -3/2, there's a wall, and it'd be nice if the wall was straight. And at +3/2, there's a wall. And then there will be a wall here, you know, a suggestion, not so much a wall, right? But why am I waiting to do the scale? Because now I can kind of see the regions I'm dealing with. So what's interesting is I don't have to know too much. I'm trying to figure out how to show you what's in my head. So we are doing this problem together. I created this problem. I've never done this problem before in my entire life. More than likely. I've done a shitload like it. But what I'm thinking right now is there's going to be a wall somewhere here depending on the scale. So I already know what this is going to look like. Do you guys see that? It's going to have to go this way and then go up against the wall. And I already know this is going to look like. It's going to have to come up here and go against that wall. So the only real region that I need more information about will be, of course, in the middle, and that's going to be a lot like the one we did yesterday. Right? There's no way in hell it could look like a draft because there's nowhere for it to pass through here. So what do I want to figure out? So my part D would be f of what? What's going to be good to figure out? Well, I know the y-intercept. That's one good thing, 0 4/3. So to be honest, I already know it's like this, but if you wanted to, sometimes I'll put this on the actual quiz. I'll say, you know, figure out what f of 1 is and figure out what f of, let's see, what else would I do? Maybe f of 3. I'll give you a couple of functions, values to figure out, just to give yourself a few more anchors. So what is f of 1? What do I get? It's easier if I do it in factored form, but I never put it together. It's too bad. So in factored form, I would get -5 times 3 over -1 times 5. Well, that's nice. Holy shit. I get 3. So it looks like a decent scale would just be 1, 2, 3. All right, let me stop for a minute. What's really nice, normally, I don't know why I didn't necessarily do this. Normally I will factor the top and factor the bottom, because what I just did was I plugged one into there and I plugged one into there, which is normally a little bit quicker than plugging it into there. Doesn't matter. It doesn't matter. So now I can plot my y-intercept, because now I got a scale, 4/3. I could have put f of -1 in there if I needed to, but I really don't, because I know it's going to basically look like this. And remember, the actual like vertex, not really vertex, but the actual minimum could be over there, it could be over there. It's almost definitely not going to be symmetric, but we're doing this by hand, so I don't even want to see that shit anyway. We talked about that yesterday. Let me put my horizontal asymptote in there, 1/4. It's going to be like right there, you know. So to be honest, I could have been a little bit nicer to myself and blew the scale up, maybe made this 1/2 1, but 2/2 unit. So now I've got this bad boy is doing this kind of thing. Wow. There's one more thing I want to, this is kind of a gross one to do it with though. It really is. I'm not going to worry about it right here. And then over here, what did I do? F of 3. I haven't done that yet, right? If I do f of 3, it's going to be -3 times 5 over 3 times 9. You get -5/9. I don't know if you guys are with me. So f of 3 is -5/9, which is just a little more than halfway. So it's coming like this. It's really, really flat there. All right. So it would have been, I could have been nice to myself and given myself a scale that would have pushed this up a little bit, so I had more room to play with. But this is fine. The one thing I wouldn't really make you do for this problem, because it's a little bit extra gross. Does anyone have a question on anything we've done? And then I want to point out one extra thing. I should put these answers down here. What did I do? This is -5/9. This was 3. That was here. Did everybody stay with me? I didn't hear any. Oh, here we go. I got a chat. This is a bad idea when I'm up at the board. Where'd you get the 3 and the 5 that you plugged in? I didn't plug a 5 in. So let me do this. Let me move this for a second. If I put this fully in factored form, this is normally what I would do. I don't know why I didn't do it here. And so if I want to do f of 1, that would be -5, right? If I put a 1 in, -5 times 3 over 5 times -1. So the 5's cancel, the negatives cancel. That's how I got 3. And then f of 3. And does everybody see why I picked 1? Just to kind of see, give me another anchor in here. And I picked this one just to see where it was going to be. And does it go like this or does it come up? So f of 3, again, you plug a 3 in, -3 times 5 over 9 times 3. And then the 3's cancel. That's how I got -5/9. Is that all right? Out there? Private chatter? Sounds like you're in the Army and they gave you a nickname, private chatter. Oh, you're okay. All right. So here's the one thing I want to ask you guys. All right. So that's done. That's done. Do you remember what it is? What's the main difference between a horizontal asymptote and a vertical asymptote as far as the function is concerned? What's the main difference?
It can't cross a vertical asymptote, but it can cross a horizontal asymptote as long as it gets close to it towards the end.
I love it. Look at that shit. That's beautiful. I love it. Hopefully everybody heard. So that was perfectly right. Does somebody have a suggestion on the work we would have to do to see if this actually crosses the horizontal. I kind of took a guess that it doesn't, but it could cross and then come back down to it. We saw that happen yesterday. How could I see if my function is going to intersect with this asymptote? I kind of just gave it away if you're paying attention. Let's see what happens. Maybe we'll try. Has everybody got what they want from this? I'm gonna erase this. Keep that there for me. So here's the thing. No suggestions. And let me say what I want to have happen again a lot more directly. I want to see where this function intersects this line.
Set them
I want
equal
to
to
see.
each other.
Say again?
Set them equal to each other.
Okay, you got it. And they can cross multiply, so your 4x squared minus 16x minus 48 equals 4x squared minus 9. We'll check on that. It looks like it's going to cross somewhere. Interesting. All right, this is getting neat. I like this. I don't know if you guys are with me. The 4x squares cancel. Is that cool? I can add the 48 over, and I can divide by negative 16. So it looks like it crosses at this thing, whatever the hell that is. What is that? It's like, it's almost 2.5. It's almost negative 2.5, but it's like 2.4 something. I don't know. Are you guys, is there anybody still with me? Anybody? So if I want to know where one function crosses another, I just set them equal to each other.
You
The
said it
4x
equal to the y-intercept, correct?
Say again?
You said it equal to the y-intercept or the y-asymptote?
The asymptote, because the
The
whole purpose,
asymptote, okay.
if my function actually crosses that asymptote, and it does cross it at negative 2 point, it's almost negative 2.5. So it looks like it actually crosses. It actually crosses right there. And if I didn't ask you to do this and you drew the picture like we had it, I'm fine with it. But it actually does cross and then it's going to come back down. So let's investigate it. Probably doesn't go up that high, but let's graph this bad boy and see if that actually happens. Or if I had a fever dream here. What's the most important thing is the idea. If you have a horizontal asymptote, how do you see if your function crosses it? You just set it equal to it and solve it. So this one went a little bit better than I thought it would, which is nice. Let's graph this bad boy. Let's see what happens. I desperately, well, let's see. Let me make this really, I can't police this, but do not graph the function until you are done graphing it. It will help you out so much. I think I said this yesterday, because if you graph it first, there will be things about it you won't be able to get out of your head, and then I'm going to know you did it. Because your graph is going to look a little too perfect in a few places, right? I kind of want your graph to not look good. Well, it was. Sports, Mr. Bell. Divided by, what was it, 4x squared? I know it's right behind me. But was it 4x squared? Minus 9. Okay. All right, let's do zoom 6. Dude, all right. And what I want to do, so see, something like that, if I saw that on somebody's answer, I'm like, no. Ain't no way in hell you knew it did that funky little thing, right? So I want to, so does that look like ours for the most part, right? So can you see how the actual minimum is over here? Oh, you can't, it's hard to see the board, I know, I'm sorry. The actual minimum is off to the side, right? Not on the y-axis. So what I want to look at, let me do two things. I want to zoom in a bit so I can see closer to my asymptote, and so let me first put the asymptote in there. So 1/4. But let me also change my window So I'm not looking so high up. Maybe let's just go to 3. So now I should get, there we go. And see, now you can really see, you can see very clearly it does go over and then come back down towards it. Exactly like the one did yesterday. I like it. Okay. So if you do, I'm going to stop sharing. Sorry. I'm going to stop sharing. Is everybody cool with that on the graph? So if you do this work and it comes out to have no solution, all that means is it doesn't cross it just approaches it. It doesn't cross it. And like I told you, later this semester, we'll see functions that could cross the horizontal asymptote an infinite number of times. So that's definitely possible. Okay.
What would a no solution look like? Would it be a complex or?
No. It would just be where you end up with 0 equals 7 or something. You know, remember the old days when you have no solution. Yeah, it could be a complex situation. I'm trying to think about. Yeah, you could have one with complex. Yeah. So it'd be some kind of no solution, no real solution situation, because we're not plotting any complex. Thank God. You would need color pencils to shade how complex regions are. We don't want to start doing complex functions. Okay. Cool. So that pretty much is section 5.6. And make sure there wasn't anything else I wanted to say in this one. So 5.6 was the one about rational functions. Oh yeah. Does anyone want to look at one with a slant asymptote? Can't remember how many of those I assigned.
Sure. Yeah.
Okay, let's do one with a slant. And then I might call it a night. It's already 6:30. Damn. How do I do that? All right, let's see if I can. I'm going to take one right out of here. Let's see what kind of weird shit they give you here. Yeah, okay, I like it. That one looks good. Did it make you, wait, sorry. Did it make you graph? Oh, yeah. All right, so let's see. Is there one here that's slanty? There's one. Sure. All right, we'll do that. Which one is theirs? All right. Can you factor the top? And this is one where the only way to factor 2 is 2 and 1. The only way to factor 1 is 1 and 1. So if it's going to work, it's going to have to be, you just figure out which one's negative, which one's positive, right? So the one that's going to end up with the 2 has to be positive, and the other one is negative. Is that all right? So some of you guys, the more comfortable you are with playing with numbers in your head, you could probably do that trial and error kind of thing for higher order things, higher factor. Oh my God, Jeff. Things that have more factors. There it is. All right, so real quick. What is the, well, what are the intercepts? So what are the x-intercepts? Real quick.
-1 1/2.
Yeah, -1 and 1/2. I like it. What about the y-intercept? Right? Y-intercept. Bam. What's the vertical asymptote?
Four. X equals 4.
Thank you. I mean, yeah, okay. You gotta be careful. You gotta be a little bit careful. It's a line, so you gotta follow. Now, what situation am I in? Obviously, you know, because that's the whole purpose we're doing this problem. I'm not gonna have a horizontal asymptote because top degree is higher. I'm gonna have a slant asymptote. So this book calls it slant. Some books call it oblique. I prefer slant. So who remembers how to find that? Anybody? How do you find the slant asymptotes? No? You divide. So I'm not going to long divide because the bottom is set up beautifully for my favorite little dude here. Hopefully I did that right. Did that really perfect. Who knows? So I get my slant asymptote is going to be 2x plus 9 because this piece is what would go to 0. So your slant asymptote will be the whole number part of your division. Because as I let x go to infinity, this piece goes to 0. So this wall is going to be a horizontal one that fell over. It had a rough or a good night, depending on how you define such things. So I do everything the same way. What gets interesting with slant asymptotes is my regions get compressed, or elongated. So let's see. I've got, yeah, everything's nice. One thing that drives me a little crazy is I have a vertical asymptote at 4. So my scale has to get to 4. And I've only got -1. So let me give myself more room on the positive side. I really should have, Jeff, you're totally killing your point. So I'm trying to give myself, one thing I noticed that some of you guys were doing for yourselves was giving yourself enough room to breathe. Let's see, where am I at? Oh, that's a little too much, Jeff. Shit. Give yourself too much room to breathe. Just because I ran out of whiteboard. There we go. Okay. So I've got my x-intercepts. Got my vertical asymptote. Okay. Make sure everybody's all right. Okay. And I've got my slant asymptote that requires me to have a scale here. So that always makes things a little bit freaky. But what I can do for myself is I know I want to plug 5 in just to see where it is. Because what could it look like in this region? What could it look like? This is a really difficult one to answer online, I know. There we go, Jason's doing. It could look like that, or, yeah, so it could either look here or there because there's no intercept for it to go through. I actually call these doors. These are doors. There's no doors. So it has to stay on that side or that side. So if I do f of 5, right? If I do, where should I do this? Let's do it up here. If I do f of 5, let's see, 9, give yourself enough room, Jack. I should have splurged for the bigger freaking, oh, too bad, too late. 9 times 6, right? Over 1, that's awesome. 54, all right. All right. So we get 54. Of course we do. Why not? All right? Sure. Why not? So screw that. It's going to come from way up there. I'm not going to make this scale go up to freaking 54. I'm sorry. But at least I know that it's going to come from way up here down. All right. So now let me make a decent scale. My y-intercept is 1/4. So I'm going to make more room for him. Screw the 50 thing, whatever. So now I can find 1/4 real easy. And now I can do my, oh shit, that's the other thing, isn't it? All right, I'm gonna have to make a, so here's the other thing I need for my scale. All right. Real quick word about, let's talk meta teaching. You ready? I like doing these fresh that I haven't done yet because you can follow my thought process. Hopefully you can. So you see me catching myself? Do you see what I just caught, right? I wanted to give myself room to fit the 1/4 in easily. It doesn't really matter too much because it's not an asymptote. But to do my slant asymptote, it's got a y-intercept of 9. So that's what's going to rule me on my scale here. So let's make this 3, 6, 9. Sure. So now my y-intercept is right there. And I can graph this. Jeff, you can do this, buddy. So it's going to be there, and then it's going to be up to over 1. So here's my slant. And this is where the people that have hold on, color pencils. You don't have to, but you can see how that would make this easier for me and you. So here's my slant asymptote coming into play. So now, I don't know what I was thinking earlier. So what I obviously don't have a horizontal asymptote here. That's what I was thinking. That was really, really silly. Because the whole point of a slant asymptote is, do you see how I've got a region here and I've got a region here, right? Do you see that? And where does this meet? At 4. So it meets at 17. This would be like 17 up here. So we got 50, where do you go? 54. So I'm going to definitely be up here. It's going to look like, let me move that a little bit. It's going to look like this. So when you have a slant asymptote, do you see what I mean by it? It makes compressed regions and it makes these long ass regions too. So this could have been either here, and I already knew it wasn't going to do that because there's no door here, or it's got to be up in here. All right. So one big unknown is this region back here. Wait, what is that? Let me not put those there because those aren't real points. Okay. So what do you think is going to happen here? Well, real quick, the multiplicity of both of these was 1. So it's going to go through. So it looks like, I don't even have to do any more work. Let me see. It looks like it's going to do this kind of a thing here. I really want you to understand. It's got to go through and then through. And it can't come from up here because what the hell is it going to do? It's got to approach this. So to be really certain, I could do f of 2. And if I do f of 2, I'll get 3. I erased it. Sure, I'll do over here. I'll get 8, 10, 9 over -2, which is definitely down here. So it's going to be 3, 6, -4.5. So about right here. So it looks like it's doing, so it's coming. It's got to approach this that way, and then it goes through, and it goes down, and it approaches that one that way. It probably doesn't look exactly like this, but this is acceptable work for us. Now, why do I not care about up here? Because this covers it. This is going to go forever, so I don't want something up here. Then it wouldn't be a function. All right, I like it. So last thing, what time is it? Last thing, let's check this in the calculator. because I do not, if you don't check it on a calculator, I don't understand. Right? Just don't do it first. Okay, so let's try this in the calculator and then we'll call it a day. Let me put it in here. I'll put my slant in there too. Oh crap, I didn't do that. What was it? 2x squared. Plus x minus 1 divided by x minus 4, right? Yes, okay. So let me share this with you guys. Oh shit, I gotta put the right, let me put my correct, what do you call it? Slant asymptote in here, 2x plus 9, just so we can see that happening. Wowzers, that was not right. It's still doing it. Oh, it doesn't let me do x on my keyboard. Whatever, man. Okay, all right. Oh shit, do you see it? I don't know why there's a 2 just sitting there. I love it. You're supposed to be a square. What are you doing to me? Oh, for the love of 2x squared. Oh, you're still doing weird shit. Okay, John. All right. I'm really sorry. I keep trying to hit my X button. I'm sorry. Gotta just stay away from my keyboard. 2x squared plus x minus 1 divided by x minus 4. Please tell me to put that in the right. Okay. So let's do zoom 6. All right, sweet. And of course, that is around 50 something, right? Remember that? So if I make my window, let's go up to 60, maybe let's go 65. There we go. I like it. There he is. And remember, right here is the other wall at x equals 4. I'm sorry, it's right here. Right there's the other wall at x equals 4, right? I like it. So that is good enough for by hand. It captures the main ideas. And if you do go on to calculus, you actually learn a few more things to make your by hand graphs much more precise. But this is good enough for pre-calculus. All right, that's enough. So let me know if you have any questions. Otherwise, you are free to go and enjoy your weekend.
Thank you.
You're welcome. Now I want to see that. I'm going to come back down to here. Somebody's chatting. There we go. You can see that little tiny boop, boop. All right. Oh, sure, sure. All right. I'm glad somebody else thinks it's fun. I think it's fun. All right, guys. Anybody else out there have a question? You guys good? I'm out of here. I don't see anybody talking. All right. Good night, guys.